All right, number 8 says the atmospheric pressure on an object decreases as altitude increases. If A is the height in kilometers above sea level, then the pressure, PA, in millimeter hexadecimal, I want to say, millimeter Hg, is approximated by P of A equals 760, E raised to the negative 0.13 times A. We're going to find the atmospheric pressure at sea level. And so they say sea level, the altitude is 0 km. All right, so we have a blank, and all they want us to do is kind of just plug in A equals 0. So the formula we're given is P of A is equal to 760 times E raised to the negative 0.13 times A. And they say A is 0, so the first wants us to plug in 0. Okay, so what happens if this is 0, e to the 0 power is 1, so we just end up with 760. Okay. It's property of exponents. So we're going to plug a 0 here, plug a 0 here for both of those a's, a equals 0, and that will just give us 760. You can put it in the calculator if you needed to. Atmospheric pressure at sea level. And so PA is in here, so 0 km is equal to 760. Kind of put it in terms of the problem. This told us up here the pressure is in mmHg. All right, and then we have part B. It says the atmospheric pressure is determine the atmospheric pressure at 6.194 km, the altitude of a high mountain, and then we're going to round to the nearest whole number. So now we're going to do the same thing, except we're going to plug in 6.194. So, and I'll do the calculator to solve this one. I'm going to plug that in, 760 E negative 0.13 times this 6.194. So this is 6.194. Plug that in, 6.194. And then we'll compute that. 760 second negative 0.3 times we're going to round to the nearest whole unit, so whole number, so 339, that will round the 9 up to 10, so 340, roughly about 340. And it says thus the atmospheric pressure at the 6.194 is approximately 340.